واحد. Okay. Uh, this assignment, a lot of this assignment is stuff you know, adding and subtracting matrices. So it's like you have a matrix, you have another matrix, and then you need to add them. You know, you add the first one to the first, the second one to the second one, you know. So, and they have to be the same size. So if you have something like this, a 3 by 2, and you add to a 2 by 2, that does not exist because they have to be the same size. But in question 3, for example, in your assignment, you had a B matrix, and it was 6, minus 3, 1, 0, 3, 2, and you had C, 5, 1, 6, 2, 2, 4. In fact, that was a 3. And you're asked to do a C minus B transpose. C, we have B transpose is you make the row a column. So the first row becomes a column, the second row becomes a column, and 5 minus 6 is minus 1, 1 minus 0 is 1, 9, 0, 2 minus 1 is 1, and 4 minus 2 is 2. Multiplication is a little bit different. So if you have a matrix of 3, 0, minus 1, 5, and you have a matrix of 3 minus 5, minus 3, negative 1, 5, 0, and they want to ask, can you do A times B? The size of this matrix is 2 by 2. This one is 2 by 3. These two numbers match. Yes, you can. And the result would be a 2 by 3. For the first number, you take this row by this column. 3 times 3 is 9, 0 and 1, 0. For this number, you take this row, second column. 3 times negative 5, negative 15, plus 0, negative 15. And for this one, first row, third column. Negative 9 and 0, negative 9. Here, you take this times this, negative 3, negative 5, negative 8. For this, you take this times this. That's 5 plus 25. And finally, this times this will give you 3. But if they ask you, can you do B times A? The size of B is 2 times 3. Size of A is 2 times 2. We have a mismatch, so this one does not exist. Question 8, I mean, all the other questions, I think it's easy stuff you can handle. Question 8 may be a little bit interesting. You have a matrix of 5, 0, negative 1, 3, and they want this to be cubed. To make this cubed, you gotta multiply it by itself 3 times. This is 2 by 2, this is 2 by 2, so it's possible, and the result's going to be a 2 by 2. This time this is 25, this time this is 0. Now we do this number, this row, column, 0, 0. Here we do this times this, -5, -3. And here we do this times this, 0 and 9. This is the result of multiplying these two. We take this and we multiply it by this one. A 2 by 2, a 2 by 2. It is possible, and the results would be a 2 by 2. This times this. 25 times 5 is 125 plus 0. This number would be this times this, that's 0. This number would be this times this, -40, -9, -49. And finally, this times this would be 27. This is the result of cubing this. Question 9, a silly question. You've seen it so many times. If you see question 10, it will take me forever to write it on the board. But it's a product. It's a product rule. So when they tell you A times B1, B1 would be the first column in B. So I put the first column. In the second one, I put the second column in B. And B3 would be the third column. So that's pretty much what that is. Yeah, question 11 is really ridiculous. I'll see if I can do, I can't even do a simpler example. You will learn a better way of doing this later on. I used a website for this. Maybe I can tell you what the website is. It's called Matrix Calculator. Yeah, if you Google Matrix Calculator, it's the first one you see. And I entered the matrix, and one of the options was raised to power of. So Google Matrix Calculator. I don't think they asked this question, because the way to solve it is very, very long. You will learn a quicker way of doing it later. Matrix Calculator, and you enter the matrix, and one of the options was raised to the power of, and I put the number they asked. So Google Matrix Calculator, it's the first one you see. You put the matrix, and one of the options is raised to the power of. Question 12 is good, not bad. I'll make it, just to show the idea, I'll make it a 3 by 3. Or a 2 by 2. Just to show the idea, because a 4 by 4 was too much. So you have a 2 by 2 matrix, so this is row 1, row 2, column 1, column 2. They usually call this I, they usually call this J. They want you to, this matrix is a matrix A. They want you to apply this formula for A. Aij would be -1 to the exponent I plus J. So when you apply it to this, I is 1, j is 1. 1 plus 1 is 2, so the first entry will be negative 1 squared. This number, I is 1, j is 2, so that would be negative 1 to 3. This one is 2, 1, which is also 3. Negative 1 to 3 is negative 1. This one is 2 and 2. They add to 4. Negative 1 to 4 is 1. Another matrix was, what if the entry was j minus I? So the first one would be 1 minus 1. For this one, it would be 2 minus 1 because it's j minus I. 2 minus 1. This one would be 1 minus 2. And this one would be 2 minus 2. Another example they asked, what about this matrix? Ij, I minus 1 to the exponent j. So we start with this, 1 minus 1, 0, 0 to any number is 0. Here, since this is still 1, it will be 0. This one is 2. 2 minus 1 is 1. 1 to the 1 is 1. Here, 2 minus 1 is 1. 1 squared is 1. Now the most complicated one was maybe D, when Aij was the sign of I plus j minus 1 in brackets times pi over 4. So for the first one, I is 1, j is 1. So 1 plus 1, 2, minus 1, 1. So that's 1 pi over 4, pi over 4. And the sign of pi over 4 is 1 over root 2. This one is 1, 2. 1 plus 2 is 3, minus 1 is 2. So 2 pi over 4